This video looks at comparing data with box plots in particular. Now, parallel box plots are often used to compare two sets of data. The plots are drawn on the same scale to compare the similarities and differences of the data sets within the same context. So if we look at this example, which is on fuel consumption, this parallel box plot summarises the average fuel consumption litres per 100 kilometres for a group of Australian-made and European-made cars. What do the box plots say about how the fuel consumption compares between Australian-made and European-made cars? What does each part of the box plot represent? What do you think the cross represents on the European cars box plot? So as you can see, looking at this parallel box plot, it looks like European cars are more fuel efficient than Australian cars. Okay, because in general, the box plot for European cars is lower than the Australian cars. So that would be an initial thing that you would look at. Note that the European cars has had an outline removed. So there was one car with very high fuel consumption. So it's been removed because it was skewing the data. If we look at Australian cars, 50% of Australian cars had between 7 and 11 litres per 100 kilometres for their fuel consumption. For European cars, 50% were between 7 and 10 litres per 100 kilometres. So you definitely conclude in this case that the European cars appear to be more fuel efficient. So let's look at an example. The data shown was collected regarding the age at which men and women had their first child. Compare the box plots for men and women and comment on the ages at which men and women had their first child. So we need to put our data in order. So let's look at men. The youngest age for men is 20. 23. So you might want to pause the video and do this yourself. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So for men, my min is 20. My Q1 is 25. My median is 29. My Q3 is 30 and my max is 38. Go to women. Put them in order. Okay, so for women, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our min is 16. Q1 is 17, median is 21, Q3 is 24, and my max is 31. So drawing our box plots, start with the men. Minimum, Q1, Q3, use a ruler. Maximum's 38. And our median was 29. So this is men. Women, we have a min of 16. Our Q1 is 17. Our Q3 is 24. Our maximum is 31. And our median was 21. Okay, and this is box plots comparing age of first child for men and women. So our axis has age in years. And I forgot to label our women's box plot. So there we go. That is done. So it says, comment on the ages at which men and women had their first child. Well, you can see by just looking at these that men have their first child at a much higher age than women. 50% of men have their first child between 25 and 30, whereas 50% of women have their first child between 17 and 24. Okay, so that's a big difference. We do have quite a long, our distributions are quite different as well. If you look at the men, it's very spread out, so it's got a greater range than what the women do as well. So in general, we could say that our men are having children at a much higher, much greater age or older than what women are. So complete exercise 9C, page 576, questions 6, 8, 10, 11. And if you want to extend yourself, there's an enrichment question, which is question 12.